Okay, here we go. This is the page I'm going to start with. I want to give you the rest of the shortcut rules, and then I will do some examples of some applications, I guess. Okay, so the next one is the product rule. I'm going to start with y equals 4x times x squared minus 1. Okay, so here's the thing. When we don't know any better, we think we're supposed to just take the derivative of both of these. Okay, so first of all, please note, we are not going to do that, but I'm going to show you what happens if we just do that wrong. So here is the wrong way. So y equals the derivative of 4x would be 4 times the derivative of x squared minus 1, which would be 2x. We would get a derivative of 8x. Okay, now that is not correct, just for the record, but here's what we can do. We can say, all right, let's do it correctly. Okay, so correctly right now, before we use this formula, we're going to just go ahead and multiply it out. So y equals, we're going to distribute, because we can do that. That's totally legal. What's that? 4x cubed minus 4x. And then we can find the derivative, y prime. That's 4 times x cubed. Derivative of x cubed would be 3x squared, and minus 4 times the derivative of x is 1. So our correct derivative is 12x squared minus 4. This is correct. Okay. All right, now let's use the product rule. We'll go for purple here. Okay, so here's how this works. You are going to take and consider this u for x and this v. Okay, so it looks like y prime is supposed to be u prime. So right, color code 4x, the derivative of u prime, okay, times v. V is green. So v is x squared minus 1. Okay, plus u, just plain old u, no prime. So u is 4x times the derivative of v prime, which is green, green, x squared minus 1 prime. Okay, I know what you're thinking. You're thinking, well, why would I do that when I can just do that? But that's okay. Just bear with me here. Okay, so here we go. 4x, derivative of 4x is 4. X squared minus 1 isn't derived, so we'll just leave it alone. Plus 4x, leave it alone, times the derivative of the second, 2x. Okay, simplify. We get 4x squared plus 1 plus 8x squared equals 12x squared minus, oh, dang it, I made a mistake, minus 4. Okay, remember, that's what we got right here. Okay, so you can do them either way, but eventually you're not going to be able to multiply. So, for example, let's take a look at another example. Let's say we want to find the derivative of e to the x times 2x squared minus 5. Okay, so remember we can use the product rule. Okay, so let's use the product rule first. So this is considered u. This is considered v. Okay, so y prime, equals e to the x prime, so u prime times v plus u times b prime. I didn't change my color, but that's okay. Okay, so u prime, derivative of the first times the second, plus the first times the derivative of the second. It seems like it's going to be hard to remember, but it's not. That's what y prime is for product. Okay, so here we go. Simplify. We've got derivative of e to the x is e to the x. Leave this one alone. E to the x is left alone. Derivative of 2x squared minus 5 is 4x. Okay. Apply everything together. Do the distribution. You got 2 e to the x, x squared minus 5 e to the x plus 4 e to the x times x. We could leave that alone, or we could factor it. E to the x is in every single term, so 2x squared minus 5 plus 4x. Done. Either one of these is okay. Okay, so that's using the product rule. Let's say we wanted to multiply it out. Remember what the original problem was. It was y equals e to the x times 2x squared minus 5. Oopsie. 2x squared minus 5. Okay, so if we want to distribute it, it would be 2 e to the x, x squared. Whoa, what the heck? That again. 2x squared e to the x. What's going on with that box thing? Oh, minus 5 e to the x. Okay. Now, if you notice, when we get to y prime, we're going to have a product rule anyway right here. That is 2x squared. We could find the derivative of that, and then we could find the derivative of e to the x. This would be easy to do. So it seems to me that the other alternative of doing e to the x and distributing, that would still, we would still need the product rule here. So we're not going to go ahead and do that. I think you should be good. Okay, and we'll, all right. Anyway, so there's no point in multiplying it out, you know, distribute, and then we'll have to, we're trying to get away with the product rule. Over here, remember on that first example, we totally, on this one, we totally didn't use the product rule. Okay, so here we go. Quotient rule. All right, the quotient rule. Let me give myself a little room. It looks complicated, and trust me, it's not easy. But let me remind you of when we did this derivative. Okay, we got a quotient right here. Let's see, our snippet. I got a quotient. It looks like 7 and 8. They were both quotients. Okay. All right, so those are both quotients. If you take the derivative of the top, you get 0. Really? You can't do that. Okay? So let's say 7. If you just completely thought, oh yeah, let's just take the derivative of the top. Oh well. And the derivative of the bottom. Okay, you're going to get 0. That's not the derivative of 7. If you want to look here, look what it is. Here's my solution. Number 7 looked like, and we're going to do it here using the quotient rule. Here's 7 right here. This one right here. Okay, I'm just going to paste it so that we're going to verify that. Okay, we'll just do, that's just 7, so that's good. All right, so let's try 7 using the product rule. Okay, let's get rid of this. That does not work. Okay, so here we go. We're going to take, using the product rule, we are going to take y to equal, my pen out, 3 over 5 plus x. Okay, so consider the top, u, See? And the bottom b. Okay? All right, so y prime equals, all right, now notice the top is very similar to the last one, except it's a plus sign here instead of the minus sign. Wow. Okay. So the derivative of the top, so u is 3 prime times the bottom, which is 5. Oops, I'm supposed to be in green. 5. I know y'all missed my sound effects here. Green. Okay. 5 plus x, leave the bottom alone. This time we're minus u, which is 3, leave it alone. Whoops, supposed to be purple. Times the derivative of the bottom. I swear I'm asking for those, but they're not working, so I'm going to forget the color coding. Okay. All right, so that's the top. Now the bottom, please note, it is not a derivative. It is b squared. B is the bottom, so 5 plus x squared. Okay, here we go. The derivative of 3 is 0. It's a constant. So I don't care what this is. I'm done with it. Minus 0 times 5 plus x if you must. Minus, okay, what's the derivative of 5 plus x? That would be 1. And then we have 5 plus x squared. Okay, I don't know what that random line is doing. So now we have negative 3 on the top and 5 plus x, the quantity squared, is our simplified answer. Check it out. That's what we got when we did it with that big, long solution. When we did it over here, this is what it took for us. Okay, so that's good. Let's try another one. All right, let's try y to be 2x. Oh my gosh, what's going on with that? Now I know why y'all don't like smart, because the pen is kind of crazy. Okay, 2x minus 4, and let's do x squared plus 5 on the bottom. Okay, so we're doing y prime. So consider the top is u, the bottom is b. Okay, so y prime equals the derivative of the top times the bottom minus the top, leave it alone, times the derivative of the bottom over the bottom squared. Okay, so the derivative of 2x minus 4 is 2x. 2. Oh my gosh. X squared plus 5 minus, leave 2x minus 4 alone, times the derivative of x squared plus 5 is 2x. Sorry about those random lines showing up. 2x. Okay. Over x squared plus 5 squared. Okay, here we go. All right, so let me move this down here. And don't worry about this. Oh my gosh. Right now, look at all those crazy lines going. What the heck? All right, here we go. Maybe equals. Oh my heavens. Where are these crazy lines coming from? Okay. Okay, let's see if that won't work. I shut it down and started over. We'll see. All right. So here we go. 2x squared plus 10 minus, oh my gosh, I can't read that. 2x minus 4. Let me get rid of this. And that's 2x. Wow. I swear I'm not doing anything. Okay. Minus, I'm going to go ahead and distribute here. So that's 4x squared minus 8x. Okay, over, I distributed the 2, I didn't distribute the negative yet. X squared plus 5 squared. Sorry about all those little random lines showing up. Good grief. All right, equals, combine your like terms. 2x squared minus 4x squared is negative 2x squared plus 10 minus a minus is plus 8x all over, leave it alone, x squared plus 5 squared. A few random lines in there. Good grief. Okay, we're done with it. Now, I know that sounds like a lot of trouble and like, is there an easier way? But please look at these. When we did them the long way, they weren't any better. Look, here's 7, here's 8. They weren't any better. Trust me, they aren't better. So anyway, okay. Moving right along. Let's go. Now, you have all the shortcut rules that you're going to get. Now we're going to go backwards and do some applications. Okay. Let's start here. Higher derivatives, derivative of a derivative. Remember, it's the second derivative. So let's say, okay, I'm going to try just the screen, see if that works. Okay, so f prime equals, all right, I'll give you a minute to do it. First, or your teacher could pause. All right, and then you should get negative 28 x to the third minus 3x squared plus 2x minus 0. So don't write that, okay? F double prime. Okay, get away. Oh, here we go again. Wasn't the individual thing. All right. That means take the derivative of this. Okay, so here we go. 28 times 3. 28 times 3. 684. Negative 84. What? Oh, my gosh. X squared minus 6x plus 2. F triple prime. You also might see this like this, f with a little 3 in parentheses. That means the second derivative too, or third derivative, okay? So either way you can do that. And that's the derivative of this, so that's negative 168x minus 6. Okay, let's find the fourth derivative. That's the derivative of the third derivative, so that's negative 168. Okay, and then what happens to the fifth derivative? That's 0. And so all of the rest of them are going to be. So that's why we can say find all of them, because from the fifth on, they're all going to be 0, because this is a, 0, y equals 0 is still a horizontal line, so all of the derivatives after that are going to be 0. Okay? All right, keep backing up. Let's try these examples. Okay, so we got another polynomial. Find the slope of the tangent line at x equals 0. Okay, so part A. Slope of the tangent line, all right? That means f prime, okay, of x. That's the slope of the tangent line. Slope of tangent, okay. Equals f prime. Quickly, you should be able to say that's 12x squared minus 2. Okay, now remember we're at 0, so now we say, okay, put that straight line there, just like the calculator does, and put x equals 0. Okay, that means you're going to plug in a 0. So 12 times 0 is 0 minus 2. Slope of the tangent line is negative 2. So that's part A. Part B says, find the equation of the tangent line. Okay, so the equation of the tangent line is just take the slope and the ordered pair. Okay, well, the first thing, we know the slope is negative 2 again, and the ordered pair is 0 something. Okay, so let's plug in 0. F of 0 equals 0 minus 1. So our other part of the ordered pair is x 0, negative 1. Okay, so y minus plus 1 equals negative 2x minus 0, or just y minus 1 equals negative 2x. I don't care that you have that 0. If that helps you to keep track of that, then oh, for gosh sakes, then just use the either one of those is good. All right. Now it says, part C, find the equation of the normal line. Okay, remember we talked about the normal line. The normal line has is perpendicular. So we know the slope is opposite and reciprocated, so that's 1/2. And remember, it still goes through the same point. So y plus 1 equals 1/2 x done. Okay, there's C. What about D? D says find the slope of the secant line. Oh, yay! We haven't done that for a while. Okay, slope of the secant line is the same as the regular slope formula from 0 to 5. So f of 0, so this is 0. Remember that was 0, negative 1. What was 5? All right, so now we got to plug in our 5 to get our ordered pair. So 5, what's my equation up here? F of 5, change colors here. F of 5 equals 4, yikes, times 125 minus 10 minus 1. That's 500 minus 11, 489. Okay, so 489 goes there. All right, so the slope of the tangent line is that difference of your y, so f of 5 minus f of 0. This is a regular slope formula. Get rid of these dudes. Oh my gosh. What is the randomness? Okay, we're just going to ignore them. 5 minus 0. Okay, so we are talking 489 minus negative 1 is the other y over 5 minus 0. 489 plus 1 is 490. Divided by 5 is 98. That's the slope of the secant line. And then find the equation of secant line. We have y minus, you take either one of these, I'm going to do the one again, equals 98 x or y minus 489 equals 98 times x minus 5. Okay, I'm going to get my calculator out and kind of look at all that. So, clear and clear. Okay, so here we go. I plug in my original function, which is up here. Come on, where'd he go? All right, 4x to the third minus 2x minus 1. Okay, we're going to put the equation of the tangent line in there as well, which is right here. This is b tangent line, okay? So y equals, I'm just going to bring my 1 over, 1 plus negative 2x, that's my tangent line, that's red when I graph it, and then my secant line, let's put that in there, or my normal line, let's do that one. That's my normal line, so that's, bring my 1 over, sorry, right here's my normal. Negative 1. That's not right anyway. It's supposed to be, okay, did y'all catch that? This is supposed to be plus. All right, so this is my normal line. This is my tangent. Okay, so over here we should have negative 1 plus, I'm going to do 0.5 for 1/2 x, and then go back up here and slip my negative in there that I missed. Okay, sorry about that. All right, now let's graph. I'm going to go back to standard. And I got my grid on, but that's okay. I had it on from something else. Okay, so there's my function. And remember, we're at 0, negative 1. That's my normal line. The reason it doesn't look very perpendicular-ish is because I don't have this to be square, so it's a little lopsided, but it works. Okay, and I'm not going to put my secant line in, but that's how you do all that. Okay? All right, so we've got that. We've got a couple more. I'm going to save that one for later. And let's go to the very back page and do one on this page. That's a g of x. We did one like that. And we actually did both of these. So let's go back and do this example because we did those others. Okay, so find the equation of the horizontal tangents of x equals 4. So horizontal tangents are like, I know yours is drawn in there. I erased mine because it was too distracting. But if you have this, sorry, and you've got a horizontal tangent here, you've got one down here, and you've got one down here. We're trying to figure out where they are. Now, typically, we don't have a graph already done, but we're just kind of referencing. So if you didn't have a graph, you can probably see where your horizontal tangents are, but the horizontal tangents are where f prime is going to equal, a horizontal tangent would mean the slope is 0. So we want to know where f prime is equal to 0. Okay, so that means we're going to find f prime. Okay, it's a polynomial, so it's a quick one. 4x cubed minus 4x. Okay, where would that equal 0? So we set it equal to 0. Now, you need to do what with that? Well, of course, you go to factor out x squared. Here we go again. They're always black. Okay, so x squared minus 1. So
Factor some more, you get x plus 1, x minus 1. All right, and then you get 4x equals 0, so x equals 0, x plus 1 equals 0, so x equals -1, and finally x equals 1. And there it is. There's x equals 1, there's x equals 0, and there's x equals -1. And I think I'm good. You should be ready to do the problems.